So today I'm going to talk to you about pi. And when you think of pi, you might think of or this, or if you're weird like me, maybe this. But pi is really simple. It's just the ratio between the circumference and the diameter in a circle. And today we know this value out to many, many decimal places. But it wasn't always that way. And you might be asking yourself, well, in a circle, but which circle? And that's the thing. It's any circle. About 4,500 years ago, in the year 2550 BC, humans first realized that this ratio is constant, from the smallest atom up to the largest spiral galaxy. Then, in ancient Babylonia, 2300 BC, we found that they knew pi all the way out to 3.125, but they used 3 in their calculations. Then, in ancient Egypt, which was 1650 BC, we can see in the ratio of the base and height of the pyramids 6.28, or roughly 2 pi. Although we see in the Rhind papyrus that they actually knew pi as 3.1605. Now, next we see reference in the Bible in 1 Kings 7:23, 550 BC. And he made a molten sea, 10 cubits from one brim to the other. It was round all about, and his height was 5 cubits, and a line of 30 cubits did compass it round about. Now, this gives us an approximation for pi of 3, which isn't very accurate, unless you guess that maybe they used a different person's arm for the diameter and circumference, because cubits are derived from the length of a forearm. Thus, a more accurate representation could be given. However, next walks in Archimedes, who lived 287 BC, and he used a method by circumscribing and inscribing regular polygons about a circle to narrow down the value of pi between 3.1429 and 3.14085. Next, Zhu Chongxi in 429 used the same method as Archimedes, although he probably didn't learn it from Archimedes since they were far away, and he was many years later. And he used a 24,000 and then some gon to get 3.141529. The 9 being incorrect, it should be a 6, but otherwise that was very accurate. Next, in the 15th century, we see Madhavan of Sangangmagramam, who discovered an infinite series which converges to 4, and subsequently used it to calculate pi to 11 decimal places. Then, in 1706, we see William Jones use the Greek symbol p, to denote the ratio between the circumference and diameter of a circle, which was then popularized by Leonard Euler in 1737. Next, D.F. Ferguson in 1945 calculated pi out to 620 digits, and 2 years later, in 1947, he used a desk calculator to get it to 710 digits. Next, Yasuma Kanda and Daisuke Takahashi use a Hitachi SR8000 in 1999 to calculate it out to 206,158,430,000 digits. Then Shigeru Kondo in October 19 of 2011 calculated it out to 10 trillion decimal places. And following that, Emma Haruka Awo, a Google employee, calculated it out to 31,400,000,000,000 decimal places in honor of Pi Day. So as you can see here, I've just drawn a simple circle with an inscribed hexagon, as Archimedes might have, but I'm going to take it a little bit further than he did. And so you can see here that I have a side R, a side of the hexagon broken up into 2 pieces, one of those being x, although they are both x since it is bisecting that segment, and then an angle theta. And based on simple math, theta is half of 180 divided by the number of sides, which gives us 180 over n. And then doing a little bit of simple trig, we have x equals r sine of theta. And we know that the circumference of a circle is 2 pi r, and that the perimeter of that hexagon is going to be 12 times the x value. But to standardize it for all shapes, not just the hexagon, we can say that it is 2n times the number times x. So that is 2nx. Thus, by plugging everything in here, we can get the formula pi equals r times sine of 180 over n. And we are going to use that to plug into the calculator and see what it would get us for Archimedes' 96gon, which he used for his approximation of pi. So we can just go ahead and plug in 96 sine of 180 over 96, and we can see that this gets us 3.14, which was Archimedes' approximation. If we go to Zhu Chongzi's number, when he used roughly 24,000, we can plug in 24,000 and see that this gets us his much more accurate approximation of 3.1415926. So now why is this useful to you? And what is pi used for? I mean, can't possibly need 31.4 trillion digits of pi for calculations. And in fact, no, we don't. NASA only uses about this many, about 15 digits of pi, for calculations for interplanetary travels, which have to be quite precise. However, there are two main uses. One is that you can bench test a new computer or algorithm you've designed by seeing how fast it can calculate, say, 10 billion digits of pi. And the other is that by taking a certain amount of digits of pi from a specific area of the sequence, you can form an encoding matrix, which you can then use to encode data, such as here. If we take starting at the 5th and take the next 3, we get a 2 by 2 matrix of 5926, which we could use to encode a message. However, a 4-digit matrix wouldn't be very hard to decode, a 2 by 2. However, pi goes on forever, so you're not going to run out of digits. If you want to take the 2 billionth to the 3 billionth digit, go ahead, and you can use that to encode your message. And now I'll stop because I could talk forever about this, but I'll leave you with this. Someday, we'll probably be interplanetary, maybe even intergalactic as a species. But this simple ratio, the ratio of the circumference and diameter in a circle, the thing that is irrational, even though it is the definition of a rational number, the thing that is the most linear number we know of. It never repeats or circles back on itself, and yet it is the thing that defines a circle the best. Even in 100 million billion years, we still won't know the last digit of pi.